Hello everyone. Welcome to Subsea Connect TV Fireside channel. My name is Eivind Windspoll. I'm Senior Sales Manager in Baker Hughes. Over the course of the last few months, we have had a number of technical webinars with our clients and industry peers. One of these sessions was held by Phil. Phil Potter is with me today and is our technical expert on wellhead systems. And we're going to talk about a little bit around the content of those presentations, but more also reflect on some of the feedback we received during and after the sessions. Hopefully, we can bring some new thoughts and also bring a lot of new information to you. So, Phil, thank you very much for joining me today.
No problem.
Baker Hughes, over the course of decades, has delivered a quite wide range of welded system solutions to the market, and these cover the most variants of applications you could see, obviously. And still, new technology is being developed. Can you just quickly brief us a little bit on these new technologies we are now bringing into the market?
Yeah, sure. So the Baker Hughes wellhead's been around for a long time, as you know. We actually, our latest generation of wellhead, the MS700 and MS800, been around since the early 90s and then the early 2000s as well. So we do have a good footprint in the subsea wellhead market with the products that we have. Recently, back in 2015, we felt like there was an opportunity to really create an enhanced version of our standard product, and that's what we've called as the SFX wellhead system. So that's the overarching wellhead itself, just some overall improvements there. Some other technologies more recently, we've improved or requalified our annular seal, what we've called our MS2 annular seal, just to essentially bridge some pressure containing capability and some annulus pressure capability. We've introduced some new updates to the H4 profile. I mean, everyone in Subsea Wellhead knows what the H4 profile is, and we've actually improved that interface, and we've called it the H4FX profile. Then the final piece here, we do have some other things going on with our next generation or HPHT technology, and we can certainly share some of the details on that as well.
So thank you very much for the overview, Phil. So let's go back to where you started. SFX, this was something that caught my attention about 6 years ago when we worked with a very central client, both in North America and here in Europe. So obviously, this is not a replacement for the legacy technology that is out there, but an advanced solution. And what does this SFX solution really brings to the client's operations?
Yeah, so SFX was born out of a need for standardization in the industry. If we go back to some of the legacy equipment that we had, and one example that we like to say is the raw material specification for a high pressure housing with 33 different types of raw material specifications for one product. So it's not sustainable in the long term. So we took a broad range of oil operator specifications, and we pulled them together, and we essentially tried to create this one universal spec. Now, we tried. It ended up being, I would say, we took the best piece of everybody's specification in order to create this universal spec, which on the face of it is not really standardization. So where we weren't able to fully make it, DNV had a JIP, but they worked with industry, they worked with the operators, they worked with the suppliers. They created this specification, RP0034, which essentially is a material purchasing spec, which allowed operators to buy in to utilize the specification, which ultimately helped us in creating this standard package that we hadn't been able to offer before. So one piece, standardization in the wellhead, and then from there we felt it was an opportunity for us to take our standard materials, our MS700 or MS800 that were per industry, per API 17D standards, essentially elevate the capability of that from a material perspective to meet the RP34 and essentially allow us to sell to any customer.
So pretty much what you're saying here is that when we go to material selection and definition, there is such a range of technical requirements in the market, both coming from industry bodies, but also from operators themselves. Having someone who's kind of controlling and working on aligning these, I guess that was something, maybe it was a little bit of a challenge, but also very interesting.
Yeah, absolutely. I mean, to try and keep everybody happy is quite difficult to do. So the opportunity that DNV brought to us was definitely helpful. I mean, what was really interesting about the SFX is we created this standardized material approach in supply, and so it basically introduces flexibility to our manufacturing platform. And we could utilize one forging, we could manufacture that product all the way and have it sitting on the shelf, knowing that we could ultimately sell that product to any customer that came along. In the SFX as well, it was once we had this product that we knew we could sell to any customer, we then thought, well, now we want this to be a really universal wellhead. So you thought, what could we do to make it a universal application to anybody that wanted it? And that's essentially where it brought on this fatigue aspect to the wellhead as well. So the SFX is really built around improving fatigue performance. It matches all of the capabilities in our existing equipment today, structurally, pressure ratings, for example. So it really was about this core approach to delivering the product, this universal approach to being able to utilize anywhere in the world, but also introducing some high quality to the product as well. We actually have independent third parties would watch the manufacturing process all the way through, including welding. So instead of having our customers send a third party in to watch some of the processes, we were able to do this with an independent third party and essentially remove that onus on the customer to be able to do that.
And these profile changes we talk about, this, I had a client once who asked why wasn't this just done before? Because everyone can see that the sharp edge is more subject to a hotspot than let's call it a rounded edge.
Yeah, it's definitely one where we do get asked that a lot. Why didn't you do this before? I mean, the way that the wellheads are currently designed, I would say that they're as compact, reasonably compact as you can get them. What we felt with SFX is there's this opportunity to improve just little pieces at a time, right? So you can imagine if you're able to improve a wellhead 1% at a time, every single day, right? Eventually you're going to end up with a really, really nice product. So that's what we did with the SFXs. We looked at the wellhead and took every opportunity that we could to improve the geometries. So for example, on the weld preps, we actually extended the weld preps at both the bottom of the high pressure and low pressure housings. So by tapering those down, we essentially reduced the stress concentration at the weld to 1. So that was one really big, easy way to reduce the stress concentrations in that region. Now, as part of the overall package, we actually were able to eliminate a number of welds in the system as well. So from low pressure housing would typically have, say, a ball valve sub or a mud mat latch in the string that would usually have some pipe pieces welded in between. So with these extended length forgings, by moving the weld away from any stress inducing geometries, we're essentially able to eliminate 2 welds in the low pressure housing joint or unit, which again speeds up productivity, reduces the need to have a pipe to forging weld. It's now a forging to forging weld. So the whole system is just better performing. And we did substantial testing, fatigue testing on it to actually show that we were able to achieve C-class performance in all of these welds. So it really it was a step change for us to get to that C-class level of performance. And in all of the testing we've done over 500 million cycles. We've not failed a single girth weld in this product.
Absolutely fantastic to hear about that. But that's still not enough. You continuously need to evolve your products, and as you say, 1% a day, that makes it a pretty perfect product. At some point, you never get to 100% because that's always going to be a stretch. So the next step, after working on the SFX for quite some time actually, and I understand it's still evolving from where it was a couple of years ago, we're now doing something MS, the metal sealing technology as well within the method. So maybe you can give us a little bit of information about what's happening there.
Yes, no problem. So the SFX was about the wellhead system as a whole, and specifically concentrating on the materials. With our annular seal, we've been starting to get some various discussions with our customers asking for this for enhanced performance in the capability of the annular seals as well. So traditionally you would qualify per API 17D, which requires a PR2 test and 3 cycles of lockdown loads applied to the seal, and that typically would be it. So we have started to see some additional, let's say, cyclic testing, longer term cyclic testing, some of the products. So when these requests were coming in, we said, right, let's have a look at the seal, see what we can do to really shoot for this goal of the multiple cycles that our customers are asking for, and really, I would say it's still custom made to that solution, but utilizing as much of the existing technology that we have within our portfolio today. So that was kind of the brainchild of how the MS2 Seal started.
That's great. And I also understand that there is new versions of the API 17D coming, and the requirements in the industry is also bringing the need for us to kind of not redevelop but evolve the solutions, right?
Yeah, so API is definitely they've tasked themselves with trying to introduce this additional testing into the specification. It's not going to be there for the 3rd edition of 17D, but it may be something that we look at either for the 4th edition or as an addendum to the specification. But it's essentially when you have lots of customer specifications coming through, you've got all the variability again, right? So it goes against standardization. So what API is trying to do is pull in this requirement and essentially make it an informal API requirement, so it can be controlled, and whenever an OEM like ourselves wants to go do the test, then it's a defined, clear method in order to do that kind of testing. And some of the testing itself, in particular, there's kind of 2 aspects to it. So one is cycle testing. So this is essentially annulus pressure from below and load from below. So the cycle test in the testing that we did was 200 cycles of load from below. In particular for the MS2 seal, that's 2 million pounds of lockdown load for those 200 cycles, with some pressure tests thrown in sporadically throughout the test program. Second piece was to do an extended envelope test. So that is essentially building some margin into the product. So the MS2 seal is rated to 10K from below and 2 million pounds simultaneously. So we tested the seal to 2.2 million pounds of load and 11,000 PSI. So just helps to create that margin, feel good factor, right, on the capability of the seal.
Yeah, the background of why the MS2 seal is being developed. We understand the testing regime, etc. But what does this really bring to the industry from a performance perspective, if you think about it operational wise? Because some of the clients says that, well, what I got is good enough, kept me happy for decades, and why change something which is free?
Yeah, absolutely. So the MS1 seal, which is our legacy seal for MS700, our MSSN seal, which is legacy seal for MS800, still good products. They still do exactly what we need them to do. They've been in use for a long time already. So it's very much they're still in market for those seals, and we still intend to be able to offer those seals. The MS2 was more about, as I mentioned earlier, it's just really about taking it to that next level. And so achieving the seal itself is rated, so we have 20,000 PSI from above. So it's bridging that high pressure requirement that we have. It's making the combined annulus pressure loads and lockdown loads simultaneously again that we didn't necessarily have in the existing equipment. So it just helps to push that level of performance. But it's really about the long-term integrity in the product. For any exploration well where you're not sure what you're going to hit, to any long-term production well, this is proven to be able to go through that number of cycles and continue to operate.
So, and that's great. So we recognize that the current MS Seal variants they will not be discontinued. They will still be around for many years. But as we move into maybe more harsh environments, and the customers are seeing this MS2 seal being brought into their operation, is there anything they need to prepare for, or can they just carry on as they've been used to for quite some time now?
Yeah, so from a tooling perspective, the way the tools function is exactly the same. There is a couple updates that we would have to our tooling fleet. The case and hanger running tool itself, because the seal itself actually has a lock ring on the seal, and so by landing the seal on top of the hanger, expanding the lock ring, and actually setting the seal, there's a little bit extra stroke in the seal of our standard tools. So we do have to make a change to the running tool just to accommodate that extra stroke. We've actually introduced a safety feature into the tool as well. So there's a device in here where when you land the seal on the casing hanger, you expand the lock ring into the pocket. At that moment, when you have the full engagement, there's an overpull check that we can do in the tool. So essentially, by doing this overpull check, you know you are in the right position before you try to set the seal. So it's just again, it's coming back to that confidence of knowing you've got the seal in the right place before you go and set it. So case and hanger running tool, the clean and flush tool, just to clean the pocket out behind the seal, is going to be different. Other than that, the tooling package is exactly the same. Now, one thing just to highlight is the technology is different. So we do have the case and hanger will be a different design. The internal profile of the high pressure housing will be a different design, but it still utilizes the same forgings. The external interfaces are still the same. So externally, to look at this product, you wouldn't notice any difference. And also the stack-up heights within the wellhead itself are also all the same. So we've tried to make it as minimal impact as possible to our existing fleet and to our customer operations.
Thank you very much. And now we are talking about evolution of the body, the materials, etc. to the SFX. We're talking about the seal, which is very important for the internal integrity of any wellhead and well system. Now, next step, I understand you've been looking a little bit on the H4 profile as well. So what's the H4 profile? It's also something in around but what's happening?
Yeah. So the H4 is, I mean, if you imagine the M700 wellhead's been around since the early 90s, the H4 has been around since the 60s. So it's been around a long time. Now, with all the improvements we've been making in SFX, for example, and some of the fatigue aspects, what we found was that the performance improvement was encroaching into the performance capability of the H4 mandrel itself. So there's been some questions in the industry asking us is the H4 the weak link? Under some scenarios, it may be the weak link. So what we wanted to do was go into look at the design and see what simple things we could do to enhance the design ultimately. So basically doing side-by-side comparison of the H4, existing H4, we improved some of the geometries, stress reducing geometries, nothing complicated about it, but essentially just really helped to smooth out and reduce those stress concentrations that we were seeing in some of the routes, for example. So by doing that, we're actually able to analytically improve the performance of the H4 profile, especially when comparing to the Baker Hughes legacy connectors. So for example, the E/F connector, which is a smaller, more longer term connector that we have, a wellhead connector, we would be able to improve the performance up to 2 times, improve the life on that one. Then our DWHD connector, which is our 5.25 million foot-pound rated connector, able to improve that performance up to 4 times. So it was really just this. It was not that it was a problem in performance, but it's felt that there's an opportunity to really create that step again in the performance improvement to the profile. And one thing just to quickly add on to that is there's no effect to interface compatibility with any of our connectors that are out there, and also structurally it maintains the same structural capability between the connectors and the wellheads that we currently have.
So which is really great from a technical perspective and also for a kind of adoption perspective. I had a chat at our Subsea Connect event last fall, and that client spoke very broadly about the need to do interventions and extend the field life. So it is a modification to the H4 profile, the namely H4FX profile. Will that help on that, or is it only addressing the accidental load factors?
Yeah, so it really is. It's twofold, right? It's improving the life and the capability and improving the structural. So it's nothing is affected from a legacy perspective. The good news here as well from licensing, we're actually going to be licensing this profile as well. So any of the other OEMs that are out there can also utilize this profile. And so it will be done in a standard 27-inch mandrel version, which is essentially the smaller wellhead that doesn't have the bump that we call it on the outside to improve the structural loads, but also on the DWHD profile as well. So the license profile, all of our wellheads currently going through manufacture have this profile on it. And we're actually looking, because it's improving the geometries, you can actually have them backwards compatible to modify existing equipment if necessary to put this profile in as well.
Thank you. And then, because now we have done everything we can with the wellhead, as I can imagine, but you talked about the next generation wellhead system. Recognizing the industry now is moving from mature areas to new frontiers, also in the oil and gas. So, and where it's a little bit more harsh environment, it's a little bit deeper or quite a lot deeper. And you talked about your introduction here, the high pressure, high temperature 20K technology being brought to the market. So can you maybe just give us a small flavor of that and what that means?
Yes. So next generation, if you've heard that, it's essentially the technology that we're looking at to bridge to the high pressure, the high temperature requirements. With the MS2 seal, we currently have a 20K rated seal available for the industry. We actually have a variation on that seal installed in the Gulf of Mexico back in 2019. So we have installed 20K capable products. The main difference here is getting to that HT. So anything beyond the 350 is considered to be high temperature. So essentially the next stage of what we're looking at for the future proofing of these wellheads is mainly around increasing the annulus pressures of the seal assembly, increasing the lockdown loads of the seal assembly, and also increasing the casing weight carrying capability of the system. So looking to take it from our existing 4 million foot-pounds up to 6.5 million foot-pounds. That's essentially, it's accommodating for your heavier strings and your casing, your thicker wall, for example, your higher pressure ratings. So really just building out the capability of that interface. Then at the same time, looking at really increasing that structural capability, like you touched on the wellhead as well. So structurally can be a problem in shallow water. You can imagine you're super shallow, you have a dynamically positioned rig, in your watch circle, right, can be very, very small. So you just have to be careful or cognizant of that fact. So by having a more structurally capable wellhead, it's also going to open up some of those opportunities as well. Submudline, we've made improvements to our 16-inch, our 18-inch, and our 28-inch. So that is, again, just helping to increase the capabilities. 16 and the 28 are fully qualified. We're just going through the test program for the 18-inch as we speak. And then the structural capability of the wellhead itself, looking to take that from our existing 7 million foot-pounds of bending up to, so combining the loads, we have 9 million foot-pounds of bending with 4 million pounds of tension. I realize I'm throwing lots of numbers at you, so I apologize, but it's really taking it and just pushing that envelope. And we're looking to do some performance testing later this year, probably Q3, Q4, where we're going to test that interface and really test it to some of these higher loads that we have in the system.
So that's the interface testing done, and when do you believe the final product, the full 20K capabilities can be provided to the market?
So the program that we're looking at towards the end of this year is more about proving out the interface between the housing to housing. So high pressure housing to low pressure housing. So once we have that interface done, and we compare that with our existing MS2 seal, that essentially will get us to the high pressure in a next generation style wellhead that we have. The high temperature piece of it is some seal qualification. So we're looking at the different technologies that we can do there, whether adapting from the MS2 qualification that we've done to increase that temperature rating, or in theory, looking at some new technologies around increasing the annulus load. So essentially looking at that combination of 3 million pounds load from below and 15,000 psi from below, and that's essentially our ultimate goal for the high temperature application as well.
That's great, Phil. Again, thank you very much for taking the time to have a chat around these great technology developments that you're collaborating to bring to the market. So it's been a pleasure to have you with me today. I look forward to touch base with you very, very soon. And to the audience, thank you very much for joining today. It was a pleasure that you took the time to listen to us. We welcome you to visit our bakerhughes.com/Subsea Connect TV homepage, where you can find more links to fireside chats or webinars, which we're continuously developing and bringing online for you. Stay safe and have a nice day. Thank you.